Okay, so let's go ahead and practice our transformations. I'll start off relatively simple, right? Our first one, A is equal to 1, right? So there's really no vertical stretching or compressing. D is equal to 0, so there's no movement left or right. And C is equal to 0, so we're not shifting this up or down. The only thing we have is that B is equal to a half. So we're going to take our data, right? What's our core data on a tangent graph? Well, from negative pi over 2 to pi over 2, 0, negative pi over 4, and pi over 4, we have an asymptote. We have an asymptote at the end. Excuse me, we had negative 1, 0, and 1 inside. And so to manipulate this, what we do with B, right, the period we take is pi over B. So in this case, pi over 1/2. Of course, if we divide by a half, we multiply by a reciprocal. So our new period is going to be from 0 to 2 pi. So what it does mean is we're going to be dividing by a half, and which means we're going to be multiplying all my x values by 2. So the y values aren't going to change, right? We're still asymptotic, negative 1, 0, 1, and still asymptotic. But if we multiply by 2 here, we get negative pi. If we multiply by 2 here, we get negative pi over 2. 0 is still 0. If I multiply by 2, I get pi over 2. And if I multiply by 2, I get pi. So from negative pi to pi, you can see that we've stretched out this graph. And so as far as graphing this is concerned, right, we're going to basically go over here to negative pi, to positive pi, and then negative pi over 2, and to pi over 2. And what we have is we have 0, 0. We have negative pi over 2 and negative 1. We've got pi over 2 and positive 1. And then we know we have asymptotic behavior and we have asymptotic behavior. So there would be one graph, all right, of this tangent of 1/2 x. If I wanted another period, right, somewhere out here would be 2 pi. Right in the middle, right, would be, let's see, we got pi over 2. Oh, actually, I think we'd have to go 3 pi, right? So if we go to 3 pi, right, we'd end up getting the same, almost forgot, right, because our period is 2 pi. So if I started with pi, go 2 pi over, I get 3 pi. And so that pattern will just keep repeating itself and repeating itself forever and ever and ever. So there you go. So that's all we got to do, just manipulate the data. In this next one, very similarly, A is 1, D is 0, and C is 0, but in this case B is equal to 2. So my new period is pi over 2, right? So we're basically going to be scrunching this down. So again, the core data, let me sneak it down here. For a cotangent graph, the core data is 0 to pi, right? That's where we have an asymptotic behavior and an asymptotic behavior, and then we have pi over 4, pi over 2, and 3 pi over 4. This was 1, 0, and negative 1 respectively. So if he says the only thing we have is B, that means we're going to take all our B values and divide them by 2. Of course, if I divide by 2, that's the same thing as multiplying by a half. So my new X data in red here, right, so we're still asymptotic, 1, 0, negative 1, and asymptotic. Right? If I multiply a half to 0, we get 0. We get pi over 8, pi over 4, 3 pi over 8, and then pi over 2. So when we go graph this function, right, so we're going to break it up into pi over 8, pi over 4, 3 pi over 8, and pi over 2. So you can see the interval, right, rather than being from 0 to pi like it normally is, the period is from 0 to pi over 2. And then our action, well, along the x-axis we have a vertical asymptote. At pi over 2 we have a vertical asymptote. At pi over 4 we're 0. At pi over 8 we're 1. And at 3 pi over 8 we're negative 1. So there would be the graph of tangent, right, over that interval. Okay, and as a matter of fact, if you wanted to go down out to negative pi over 2, right, that action would be similar. right? So just left or right, that same action over 0 to pi over 2 would just keep repeating itself over and over and over again. Okay, so started off simply. A was 1, D and C were both 0, and then B was changing, and all we are doing is impacting X values by dividing them by B. That changes the data, and then we can go get the new sketch and kind of see how the data has changed. In this case, all we did is play around with the period. Rather than from 0 to pi, right, we either stretched it out or we compacted it in and compressed it. All right, so let me go to another video where we'll do a little bit more. You can see it's coming. A is there and B is there. So we'll put those together in one full swoop. But I'll do that in the video coming up.